So, I'm Christina Tondevold, the creator of the Build Math Minds Facebook group, and I'm also known as the Recovering Traditionalist. Now, I call myself that because I used to teach math very traditionally. I would stand in front of the class and give them the step-by-step directions and procedures to solve certain math problems. And we would do the problems together, and then I'd give them the set of problems to work on by themselves. And I quickly learned that that did not work for a lot of my kids, but I didn't know what else to do. It wasn't until I went back and got my master's degree that I was introduced to cognitively guided instruction and lots of other insights that changed the way I personally thought about math problems and the way that I taught it to my students. So I know what it's like when we are that teacher who's doing the best we can with the knowledge we have right now. And at every given point in our teaching, we never really sit down and plan a lesson thinking, I'm gonna make this as bad and as horrible for my students as possible. Right? That is not what goes through our mind. We always have the best intentions for our students, but as we learn more, we change our teaching. Inside of the Build Math Minds Facebook group here, we had a post last month asking for a way to teach borrowing to a second grader. Now, I know many of you cringed even as I said that out loud. And many people in the comments did also. But remember that people are doing the best that they can with the knowledge they have at the time. You don't have to see the comments to see that many people may not have been very nice in that post, because the original poster actually came back and updated it to say, I am not their primary teacher, but working as an intervention teacher. The curriculum has already introduced them to the algorithm, and the primary teacher uses the term borrowing. So you can know that people were in there saying, why are you teaching it to them? Why are you saying borrowing? And many of us know that borrowing is not the correct term, but many people don't know, because that's what we grew up with. We grew up calling subtraction, what we're doing when we're doing that subtraction algorithm, borrowing. So you don't know that it's bad because that's the way you were taught. And so there's a lot of people out there still doing the traditional way because that's what we're used to. And I know that I would probably be one of those people if I hadn't had the experiences that I had many years ago when I went back and got my master's degree. I would still be one of those who was doing that algorithm and teaching kids those steps. But today, as our hot topic, we're going to talk about why subtraction with borrowing is bad and what else we can do when the textbook and people around you are using it, right? Because no matter what, even if we all say, we all know here that we shouldn't be doing that, we shouldn't be calling it borrowing, kids are still going to be exposed to it, whether it's from another teacher, a parent, a sibling, whatever it might be. So let's first talk about why it's bad, and then we'll talk a little bit about some alternatives, like when you see that happening, what are some things that you could emphasize instead to help the kiddos out. Okay? All right, I'm gonna bring up a screen here. Okay, let's hop into this. So the big concern here for me is that our textbooks are not aligning with our standards. If you actually go into the standards, you will find that multiple grade levels talk about having kids use strategies to help them when they are adding and subtracting. So first grade has it, second grade has it, third grade has it. There is not a mention of the algorithm, which is where that borrowing comes in. The algorithm does not appear until third grade. And it just says algorithms. The standard algorithm that we all associate with the borrowing, or better known now as regrouping, we'll talk about why that's changed also, but the standard algorithm happens in 4th grade. Now, unfortunately, all the textbooks still have the traditional algorithm for subtraction at 2nd grade. And they get away with it because they say, well, it's a strategy based on place value. That's what 2nd grade says. Kids need to be using strategies based on place value. But does it really? Does the algorithm really emphasize place value? I say no. In fact, I believe it de-emphasizes place value. It puts no emphasis on place value whatsoever and makes it harder for kids to develop their place value understanding. So let's take a look at this 57 minus 19. The traditional way that we used to teach this, I know we use better words and everything now, but we would tell kids, well, you can't take 9 from 7, so you have to come over and borrow 1 from the 5, right? Like, that's not the terms we use now, but there may be people who are still using that. First thing, you can take 9 from 7. Yes, you can. That's why kids struggle so much with negative numbers. But at least say, if we did take 9 from 7, we would go into the negatives. Maybe we don't want to go there. Okay, at least put it in their brain that it's possible to take a larger amount from a smaller amount. Kids need that in the early grades, even if you're not teaching negative numbers. Okay, I'll off my soapbox on that one. That's a whole different story. But just the place value, there was no mention of what things really are. When I take the 1 from the 5, the 1 is really a 10. The 5 is really a 50. But we don't say it in that way, or we didn't when we grew up. I know that we do better now with explaining it a little better for kids, but still, the way that it looks, if all you look at is just the symbols, that 7 magically becomes 17 somehow, but yet the 5 becomes a 4. It doesn't help kids really see any of the place value understandings about these numbers. And then even the next steps of when we go to subtract, we say it as 17 minus 9, 4 minus 1. There is no place value understanding at all in the traditional algorithm, unless you as the teacher are bringing it in. And I know many of you are, but the hard part is that we know that kids don't always hear everything that we say. Instead, they're seeing what's on the paper or on the screen, and this is what they see. They don't see any place value understanding whatsoever with the traditional algorithm. And that is concerning because that is a huge, huge piece in 1st, 2nd, 3rd grade. We need to be building their place value understandings and, as the standard says, strategies based on place value. I do not believe the traditional algorithm focuses on place value. So some people will say, oh, it's based on place value, so we can still do it in 2nd grade. I don't think so. Okay. All right. So here's a little side-by-side comparison of our standards that deal with addition and subtraction. That's the stuff on the left. And then the stuff on the right is our standards that deal with place value. Now, for too long, mathematics has always been taught in isolation. We're working on addition and subtraction, and then later we're working on place value. Or we work on place value first, and then we're doing an addition and subtraction. Like, these need to be done together. All of it works together to build this cohesive understanding. And if you jump too quickly to that algorithm, it becomes very difficult to help kids build the understanding of place value. Where if we actually focus on strategies that are building place value understanding, we get both at the same time. Addition, subtraction, and place value work at the same time. So I'm not going to show this entire video clip here. We'll post the link in the comments when we're done here. But I just want to give a brief little description of it. It's only, I think, maybe it might not even be 8 minutes. It might be 4 minutes. But the gist of what happens here at the end, this is a clip that Marilyn Burns did, showing how students can show you that they have an understanding in one situation, and then all of a sudden in a different situation, it's like, where did that understanding go? So at the beginning of the clip, it's showing this little girl, Sina, showing that she's got this wonderful place value understanding. And then Marilyn's sitting down with her, and one of the tasks that she has is they've counted out 18 of these little cubes, and the girl wrote down the number 18 on the piece of paper. And then Marilyn asked, so these were 18 cubes. You told me we had 18 here. You counted them out. Can you show me with the cubes this number right here, the 8. Show me the 8 with your cubes. And she counts out the 8, right? And then she goes, okay, so show me the 1 with your cubes. No, she didn't just say, show me the 1. Sorry, this is why I should have had shown you the actual video. She uses a specific phrase, and she says, show me the value of the 1. Show me the value of the 8. So show me the value of the 1, and Sina put 1 of her little cubes up there. And then Marilyn presses her and says, but I see you've got the 8 here and 1 here, but when we counted, you told me all of these cubes make 18. So where do these other ones belong? And then she pushes them to the side. She's like, I don't know, it's 1 and 8, right? So that's a quick little check to see, do your kids actually understand the value of those digits? And if they don't, we've really got to focus in on building that place value understanding way before we ever introduce that traditional algorithm, because that traditional algorithm is so easy and so quick, and it does not require any thinking, hardly at all, especially place value thinking. And so if your kids have been struggling with place value and then they get introduced to that algorithm, they're really going to struggle with place value. So again, we'll link that up so that you could take a look at the full video if you want to. But we really want to emphasize place value. The other thing that I do not like about the algorithm is that it doesn't show the decompositions or compositions of the numbers. Okay, so let's come back to this one again. This is what it looks like when we set it up and show the algorithm steps. And what kids who struggle, kids who have kind of grasped that number sense and place value, and they have that already, they understand what these mean. But for our struggling kids, especially when we introduce it too early, all that they're seeing on this is now they see 417 minus 19. And somehow that magically becomes 38. So overall, in general, there are 2 complaints we hear from parents, from teachers, administrators around mathematics. Kids struggle with place value and they have no sense of numbers. Like they can't even tell if an answer is realistic or not, if it's reasonable. Well, look at that. Like, it's 417 minus 19 and somehow it becomes 38. Right? Just the symbols there make it very hard for kids to actually tell reasonableness. So instead, an alternative way in the early grades, before we actually introduce the algorithm, is to set it up similar to this. Some people will call this expanded form. Some people call it partial sums. I don't care what you call it. I just want you to understand it's a great way to show the kids what's actually happening in that algorithm before we ever introduce the algorithm, right? We can break it apart and show that 57 is 50 and a 7, that 19 is a 10 and a 9. And we've got to take away a 10 and a 9 from those numbers somehow. And then when we start with the ones and we say, 7 minus 9, and some kids will say, we can't do that, right? We want to explain, well, we can, but we don't have enough. So let's come over, and this is where the whole borrowing, we're going to borrow from the 50. But as many people mentioned in the comments, we're not borrowing because we never really give it back. So the term of regrouping came about, and the reason we call it regrouping is because we are taking the 57, we're just grouping it in a different way. Who says that it has to be a 50 and a 7? I can regroup 57 into anything I want. The algorithm regroups it in a specific way, but you can really regroup it any way you want. So with the algorithm, we take 10 from the 50, and then we see that we're left with 40, and that 10 we regroup over into the ones, and now we have 17 and 40. But the key here is not just the steps and procedures that we're sharing with kids. It's to help them see that we've decomposed 57. We broke it up into chunks that were easier to subtract from, but that it still is, so there's the rest of it to solve it, but it still is 57. We still have 57 there. We've just regrouped it. We decomposed it, but I can compose it back together and I still have 57, the original amount I started with. That's a really big thing to emphasize with the kids, is that when we're doing these strategies, we're doing things where we're breaking apart numbers, we're decomposing, but we still have to know that we can compose it back together, and that's why we haven't changed the problem. It's still 57 minus 19. I'm just regrouping it into better, easier numbers to subtract a 10 and 9 from. Right? And there's nothing to say you have to do the 40 and the 17. You could regroup it in lots of other ways, but this one leads us into the understanding of the algorithm. Okay? I can hear all those little beeps happening, and I know it's from people leaving comments or liking or things like that as we're going, because we're doing this one live. So I know when you watch the recording, you're going to hear all those beeps in the background. I got to figure out a way to make those not happen when we're doing the live training, so you don't hear them on the replay. But let's take a look at what this looks like, even as kids get into larger amounts and 3-digit minus 2-digit numbers, or even 3-digit minus 3-digit. I mean, it's how you could do this with however big of a number you want to. But for the sake of being able to show it here, I kept it somewhat small. Right? So helping kids see that all they're doing is we've broken apart the 245 into the 240 and 5. We decomposed it. But we don't have to decompose it in that way. We can regroup it into ways that are more friendly to then be able to subtract, right? So that is what it would end up looking like if we showed it in this way instead of just the algorithm, right? When you just have the algorithm, it's just a bunch of symbols up there that become really confusing to kids, and they don't really see those decompositions. And then again, the important part is talking about, do we still have 245? And you know what was really nice? I didn't leave it on here, but I'll admit it. When I was typing up this slide, I had 100 and then 140 and then 15, right? Because I was trying to skip a step and not show the 30 and then moving the 30 into 130. But when I did that, I made that error. I left it as a 40 there. And it wasn't until I went to go put the circle around it that I realized that doesn't add up to 245. It doesn't compose back to the original amount, right? So that's a way for kids to be able to check and see, did you break it apart? Did you decompose it correctly so that it still is 245? All right. So how do we actually help kids with this? The biggest thing is focus on place value. Now, the hard part is most of the activities that we have in our textbook, and even when you go Google place value activities, the emphasis is usually on the place. What place is the for? Right? Activities like that. Put the place next to the digit, right? You got to drag this over to the tens column, those kinds of things. That's an electronic version of it. Here's another worksheet full of just having the kids put hundreds, tens, or ones for whichever place the underlying digit is in. That is emphasizing the place, not the value of the digits. And we need to spend more time emphasizing value. Like here's another one that's on the right track, but I still have a little bit of issues with this. So I love that we're bringing in place value blocks that helps emphasize the value of the digits. But the hard part about this activity is that you could possibly get a false sense of security that your students understand place value. just because they could match these things up. The reason that becomes false is because there's no other options. Like if you look at that, it says 3 10s, 5 1s. Well, there's only, like if you're just looking at the digits, I could just look at digits, not even thinking about value. It has a 3 and a 5. Oh, the 30 has a 3 and a 5. Oh, those base 10 blocks, there's one that has 3 and a 5. I don't even have to really think about the values. All I'm looking for are 3s and 5s. I'm not looking for a 30. I'm not looking for 3 10s. I'm looking for a 3 and a 5, right? And it can give you that false sense of security thinking your kids actually do understand place value when all that they were looking at were those digits, right? That's it. That's all they were looking at and looking to see which ones matched up. So I want to encourage you to emphasize value. How do you help emphasize value? It's by doing lots and lots of bundling and unbundling activities. I don't care what you have kids bundle, but getting things that where you're counting a big set of stuff and we need to bundle them into groups of 10 to keep them organized. And then when we get 10 groups of 10, we're going to bundle it into 100. But it's also not enough just to bundle. Kids need to unbundle things as well. One of my favorite activities comes from Kathy Fosno's work, The Context for Learning. There's a book inside of Context for Learning called the Maslapi Family, and it's all about that they create this t-shirt factory and they have to bundle the t-shirts into bundles of 10 so that it makes keeping their inventory easier. And then as they sell t-shirts, they unbundle the t-shirts. It's a fabulous, fabulous story to help you have kids see a context that goes along with the bundling and unbundling. There's a whole series of books, and I believe you can find them on Amazon as well, but this goes with the t-shirt factory. There's a whole lesson kit that goes with it that I highly recommend if you can get them separate. I believe they sell them separately now, not just as a group. We've got links to them there. I will put those into the comments as well when we're done. So let's come back to this one really quick. Just a slight little change that I would make to the traditional type of place value activities like this. So watch the screen closely. That card that says 3 10s and 5 1s. I'm going to switch it up just slightly. 3 10s, 5 1s. And flip it to say 5 1s, 3 10s. Sometimes it's just as easy as that because the kids will want to put that as 53. They're so used to us and our textbooks always putting it in order. We always say the 10s and then the 1s. And so all they have to do is grab the digits and then put them in order. Just by flip-flopping the order sometimes, you'll be amazed at how many kids get tripped up by that. Okay, and then watch again, I'm going to modify the place value blocks for that same one. So the 35, the place value blocks that are in that row, let's take a look at how we could maybe change it. It's still 35, but now it's 2 10s and 15 1s. And again, why is that so important? It's important because that's a big part of that algorithm. That's what we're doing to help kids move into the algorithm is not just see 35 as a 30 and a 5 or 3 10s and 5 1s. We need them to be able to see it as a 20 and a 15 or even a 10 and a 25. We want kids to be able to decompose and compose them back together. And we don't want to give them the easy decompositions all the time because unfortunately, they're onto our tricks and they'll just look at the digits of things instead of actually building their place value understanding. So here's another one back when we actually collected box tops before they became, oops, oh, I went backwards, sorry, dropped it. Before they became all digital. This was something I made my own personal kids when they had to turn in their box tops. We would organize them into groups of 10 and we put them into little trays. And then when they had those 10 groups of 10, we would put them in a Ziploc baggie and then each Ziploc baggie was worth 100. So just anything that you are having kids collect. If you collect the tabs on Pops, from cans and stuff. Have kids bring those in and ask if your class can be the ones who count them. Any kind of thing where you get the opportunity to have kids bundle and then even unbundle those together. Another one of my favorites are these base 10 riddles. I'll put these up here. You can look at them later. I'll put a link to the slides. I know I'm going through a lot of them. I'll put a link to the slides after I get done here. But these are excellent ones. These come from John Vandewaal and Friends, the book Teaching Student-Centered Mathematics. But it's all about giving kids these base 10 problems, but mixed up a little. He calls them base 10 riddles, because typically, like this first one, I have 2 10s and 13 1s. The place value activities they tend to get, it will just say, I have 3 10s and 3 1s. What am I? And all the kids have to do is just pull the digits out. But when we put it in these mixed up ways, they really have to think about that bundling and unbundling themselves to figure out the amounts. Okay, so there's some examples for elementary, early elementary, and upper elementary. Okay, here's a quick little check-in that you can do with your kids, and we'll do it here as well. Just to see if they have a place value understanding, a complete place value understanding. So how many 10s are in 53? You could say it to yourself, you could write it down, put it in the comments if you want. How many 10s are in 53? Now, how many 10s are in 243? I'm going to pause there, I think, because this is the one that tends to trick people. And you may think that this is a trick question, but I'll show you why it's not here in a moment. We are so used to just asking kids what digit is in the 10s place. So in the first one, kids will naturally say 5. There's 5 10s in 53. But then when we give them the second one, they want to say 4. They want to say that there's 4 10s in 243 because they're so used to looking at what digit is in that place value. Now, if I asked what digit is in the 10s place, the answer would be 4. But I'm asking how many 10s are in 243. That's a completely different question, and it trips up even adults. I know it tripped me up the first time I saw this task. I said 4. I'll admit it. I said 4. It's really 24. And why? How is it 24? Right? I mean, we can put it into all kinds of contexts, but let's put it this way. If I went to the bank and I wanted to get cash out and I asked for $243 in 10s and 1s, how many 10s would I expect them to give me? I don't want just 4. I need 24 10s to make the 240, right? If I have 243 cupcakes and I can put 10 cupcakes in a box, how many boxes am I going to need to hold my cupcakes? I'm basically asking how many 10s are in 243. We have these scenarios all the time in our lives, but we don't ever think about it in this way. Those kinds of scenarios are really asking how many 10s are in 243. All right, here's a little bit tougher one. How many 10s are in 1,037? And for most people, they will say 3, right? But now, how many 10s? If I went to the bank and asked for $1,037 in just 10s and 1s, how many 10s should I get from them? If I have cupcakes, if I baked 1,037 cupcakes and I could put them into boxes of 10, how many boxes am I going to need? Right? Those are scenarios like that. If I think about the t-shirt factory, Grandma Masloppy has 1,037 t-shirts and they're bundling them up to put them into inventory, and for every 10, they bundle them up with a rubber band. How many rubber bands are they going to need? Whatever it is, if it's stickers on sheets of paper and you can put 10 stickers on a sheet of paper, how many sheets of paper am I going to use? I don't know what your scenario is. Think about a scenario that would resonate with your kids. But that's a big piece that we want kids to be able to understand. And it's super important because of problems like this. This candy factory problem, where they said they have 48,638 candy bars, and they're going to put them into boxes that hold 100 candy bars each. How many boxes will they need? They gave this problem to 6th graders, and only 9% of 6th graders answered that correctly. The majority of those 6th graders in that study tried to do the operation. They tried to do long division, and you know how horrible people are with long division. But essentially, all that problem is asking is how many hundreds are in 48,638? How many hundreds are in that? We want kids to be able to do operations, whether it's addition, subtraction, multiplication, division, but we also need to build their place value along the way. And too often, our algorithms, not just subtraction, even addition, multiplication, and the long division algorithms are devoid of place value. They don't help kids decompose and compose numbers. It is just a bunch of steps that kids aren't really connecting to. And I got an email a while back from someone who had asked, what if kids only want to use the algorithm? Because the algorithm is just so easy, but it doesn't take thinking. The teacher knew, I don't want kids to just use the algorithm, but the algorithm had already been introduced to them. And once the algorithm has been introduced, it's very difficult to get them away from it because it is so easy. It's so easy, and it doesn't take any thinking. It takes no number sense. It doesn't take any place value understanding, right? It takes none of that. We want kids to be able to use place value, use their understanding of numbers to help them do those operations, okay? So again, no matter what, no matter how hard you try to avoid the term borrowing or not introduce the algorithm too soon, you're going to have students who have a different teacher, a parent, a sibling, whatever the case may be, that introduces that terminology or the algorithm to them. So as much as we can, we want to connect what they've seen with that algorithm to place value. Build their understanding of place value, show the connections between them so that kids aren't just seeing it as another separate thing. We want them to use their understanding of numbers, of how you can decompose numbers, compose numbers, and of course, their place value understanding. So, as always, I hope that this helps you build your math mind so you can build the math minds of your kiddos.